Welcome back to Apex Waves Tech Tips. In this tutorial, we're walking you through how to generate digital output and pulse signals using Python, the NI-DAQmx API, and the NI-USB-6353, a versatile multifunction DAQ device. Here's what you'll need to follow along. NI-USB-6353 connected to your system. NI-DAQmx driver. Python, Windows version recommended. Pip, Python package manager. Once your software and device drivers are installed, plug in the USB-6353 and open NI-DAQmx to confirm it's recognized. You should see it listed under Devices and Interfaces. Now in Python, we begin by importing the NI-DAQmx Python library, along with the acquisition type class, which helps define how our task will behave. If you haven't installed the NI-DAQmx API yet, pause here and run the following command in your terminal. Pip install NI-DAQmx. To generate a time-based pulse train using a counter output, we start by creating a new task using a with statement. This ensures the task is automatically initialized and cleaned up once complete. We then add a counter output channel using add_co_pulse _chan_time, specifying the name of our device, test in our case, and the counter channel CTR0. This command allows us to generate a square wave by defining two parameters, high time and low time. In this example, we've set both high and low times to 500 microseconds, which results in a 1 kHz square wave signal. Next, we configure the timing to continuous mode using CFG_implicit_timing. Without this, the device would output only a single pulse. Finally, we start the task with task.start, and it continues to run until the user presses enter. Alternatively, you can generate a frequency-based pulse train. The structure of the code is nearly identical, but instead of defining high and low times, you simply specify the desired frequency using add_co_pulse _chan_freq. Once again, we define the device, test, and channel CTR0, and then set freq equals 1000 to output a 1 kHz signal. This is a simpler way to define the waveform if all you need is a steady pulse frequency. Now let's move on to digital output. In this example, we'll write a digital high signal, true, to port 0, line 0. This could be used to activate an LED, a relay, or any connected digital component. As before, we use a with block to define our task and call add_do_chain to add the digital output channel by specifying the device, port, and line. In our case, test/port 0/line 0. Once the task is configured, we call write true to output the high signal. Next, we'll read a digital input. We create a new task and add a digital input channel, test/port 0/line 1. Using read, we can check the current state of line 1. If line 0 and line 1 are physically connected, for example using a jumper wire, this read should return true, matching the signal we just wrote. This is a simple and effective way to monitor sensors or validate that your signal is reaching its destination. To test signal changes, we then write a low signal, false to line 0. After that, we read line 1 again. If your wiring is correct, this time the input should return false, confirming that the change in output was successfully detected. And that's it! In just a few lines of code, we've created a pulse train, controlled a digital output, and verified a digital input, all using Python and NI hardware. This foundation is perfect for building more complex DAQ systems, automated tests, or real-time monitoring tools. This concludes our tech tutorial on using NI-DAQmx in Python with the USB-6353. If you have any additional questions, please visit our website at apexwaves.com, where our dedicated team is ready to provide the support you need. Thank you for watching. Don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.